Hello, this is Andrew, and in this video I'm going to show you how to make a diamond-pocketed belly pan with electronics mounts. So I'm right now making this video for the TKO student robot project, but I hope that in general the knowledge here will be usable year in and year out. So we see this drivetrain we have right here. We've got a swerve drivetrain with 2x2 aluminum tubes. We got West Coast Products SwerveX modules in the corner. And we want to add a belly pan into it. So this is the assembly that we have so far. If we go over to our part studio, we have these two parts made right here. Excuse me. So these tubes are the drivetrain tubes, as seen in the positions of the drivetrain. So if we actually go into our master sketch here, you actually see the sketch drawn out so that everything is in the correct location. You see the little swerve module over here in the corner. I know the student robot project does not have it in this orientation, which makes things harder, but I trust that you will be able to figure out on your own. The solution between what you have and what I have is not too difficult to solve. So our belly pan is going to go underneath the tube. So we're going to go down there and select a face and click Shift S, which is creating a sketch, and N to go normal to the plane. So this is what we have right here. We're at the face at the bottom. We're going to start with a large rectangle. So I'll use the rectangle tool. And I want this rectangle to be slightly overlapped of the innermost layer of holes on each tube. And since this is the center of our robot, we know the other tubes go here and here. We can just use these two as the reference. So I'm going to place a point inside some of these holes. So that just gets me the center of the hole to reference. If I were to dimension off of the hole by itself, as I'll show you here, if I try and dimension off this hole to this line, it's going to give me either like the least or the greatest distance for some reason. And I can think if I can go to the far end. Yeah, it'll give me like the greatest distance. And I don't want the edge of the hole. I want the distance to the center. So I put a little point in there. I use Shift S, the same command to start a sketch. It gets you a point when you're in the sketch area. Or I can come up here, select point. See how it says Shift S up there. So I put a point in the middle of those holes. And I'm going to dimension from those holes 0.25 inches. Or from the point, sorry. So we want to go about a 1/4 inch out. I like this value for two reasons. The first is that we minimize overlap with the other sides. So we're not covering these other holes. They're still useful for other things. And also it keeps our belly pan no bigger than it needs to be. This is all we need. You don't need double layers of mounting. So we'll keep it there. And you can see our sketch is now fully defined. We have a center point for our center point rectangle, and then these two dimensions dimension the length and width. Because this is all top-down design, it's all referencing other previous features. So if we click, we can go down here, we can see our width. It says length, but our width for our belly pan is 25.5. Our length is 28.5. I always use, in a rectangle, I say width is the shorter dimension and length is the longer one. That doesn't really make sense. It's just some arbitrary system I've used over the years. I don't know, it makes sense to me. If you have a rectangle, the width is the shorter end. But do whatever you like. But we know those dimensions, and it's important to know those dimensions. We'll come back to those later. So alongside this, we have the rectangle for the shape of it, and then we also need the mounting holes. And luckily for us, if we're designing this the right way from scratch, we have the tubes in the right locations. We can reference those holes. So I look here, I have those holes already there. So I'm going to click U for the use command. It's the use project convert command. And you see my cursor's turned into a little reticle right there, a little plus sign. I'm just going to go highlight all those holes. I want to make sure my highlighted area is over the holes, but not over the line I've made. And if I do that correctly, give it a second, it'll first select the outside, and then it'll realize I want the inside, and there it goes. It has selected all the holes. So those are now sketch entities that I can use. I'm going to do the same thing here at the bottom one. I'm just going to click and drag in there. Give it a second. It's going to select the outside. Always selects the outside first, then it realizes, nope, you want the inside. It selects the features on the inside. So we get those. Having those is very nice. However, we want them on multiple sides. So what I'll do is I'll create a little 2 sets of lines. Onshape is being slow because I'm recording, so give it some time. Be patient. I'm making these lines midpoint with the origin. I can make them construction geometry. And the purpose for these lines is to give us a mirror plane. It's going to mirror these holes over to give the mounting holes for the other sides. So over here, I go to the mirror command. It says select a mirror line. I'll select the horizontal line, and then I will just click and drag to select all these holes. Give it a second. There it goes. It even has a little point in there. That's fancy. Then I deselect the mirror command, and I'll reselect it. So again, deselecting it allows me to pick a new mirror line. So I'm going to pick the vertical line. And then let's see if I can get it outside of that command. Select these. And there we go. So we have the outline shape of our belly pan. We have all of our mounting holes. That's a good start. So we can extrude this. We say Shift E for extrude. And you can see it's extruding down from the tubes. We want it to be a new part, blindly extruded, and I'm going to say for 1/8 of an inch, 0.125. That's going to be the thickness of our belly pan. So we have this. You see the corners do overlap with the swerve. Don't worry, we will take care of those later. But for now, let's focus on getting the diamond pattern in. So the diamond pattern is a very fun part. So I'm going to open up a new sketch on the large face of the belly pan. And I'm going to do 2 things. The first I'm going to do is create a rectangle that is exactly 1/2 of an inch from the outside faces. Oh, not 2, there you go, 0.5 and 0.5. This rectangle is to define the bounds of which areas are included in the diamond pattern and which are not. So we don't want to have the cutouts where the mounting holes are. That would be silly. So we have that rectangle, and the dimensions of this rectangle are 27.5 long and 24.5 wide. Good numbers to know. So we're going to now create a line using the line tool. It'll be construction geometry. We're going to make a diagonal line from one point to the other, from one corner to the other across. And this is going to be roughly the line for our diamond. So we're going to have a continuous line that way. You'll see what I mean in a bit. We'll go up to a corner now, and we're going to make a little rectangle using 2 lines. One that goes horizontally from one face to the diagonal line, and then vertically to the other. So something like this, you should have them coincident on this line. I can drag this point and then move roughly evenly there. So we're going to have this, and then we're going to do another construction line from these corners. So it almost looks like we have like a little flag here. The big construction line going across the entire diagonal of the belly pan, and then this little one just for the section we created. Now this is a semi-quadrant of a diamond. So if you imagine what a diamond looks like, it would be like, you know, a section of this, but then mirrored across. So this is like this is half of a diamond, this is half of a diamond, this is half of a diamond, this is half of a diamond. And we're going to take these little diamond halves and we're going to pattern them to create full diamonds. But in order to do that, we need to know how big the diamonds are. So in order to know how big the diamonds are, we are going to take one of our dimensions. Usually I take the length, this 27.5. I'm going to take this dimension, this section of that distance, and we're going to make it equal to that length, 27.5 divided by some whole number. This whole number is going to be the number of diamond patterns that we're going to have. The larger the number, the smaller the diamonds, the more material that you have on the belly pan, the heavier it is. With this specific belly pan, I am not trying to optimize for the least weight. I'm actually trying to get a heavy belly pan. I'm actually going for almost the most weight, which some may find counterintuitive, but why am I pocketing a belly pan if I want it to be the most weight? The answer is I'm not pocketing for weight, but I'm instead pocketing for ease of wiring. Having the little strands of the diamonds in a belly pan it makes it very convenient to mount things to and to route wires and to tie zip ties around. So I want this to both be heavy, but also functional for our electronics. You can instead just go for a solid belly pan, in which case ignore the rest of this video. You've created a belly pan. Congratulations. Just make the cutouts for the swerve and you are good. But we're going to go along and say that we want a heavier belly pan. So I'm going to take that 27.5. I'm going to divide it by a whole number. Common numbers, if I'm going for a really light belly pan, I'll use 5 or 6, never less than 5. Heavier ones, I'll use something closer, 7 or 8. So I'm going to go to an 8. So 27.5 divided by 8. And it makes it about this size. It's some arbitrary number, whatever, 3.438, probably 3.4375, because it's a nice 8th division. And then in doing so, and in setting this up this way, this distance right here, this little short length, is 1/8 of this total line, of our length total line. And because we have that diagonal and we made these geometrically consistent, this length, this short section, is exactly 1/8 of this height. So that's a nice little geometrical solution there, which is going to make our pattern very easy. The next step is to actually create the strands for the diamond. Now, in SolidWorks, you would use this. You do this using the offset entities tool, which we're still going to do here. But the nice thing about SolidWorks is you can offset the entities in multiple directions. So I can select a line and say, yeah, I'd like you to add 1/8 of an inch of an offset to either side, and it'll create 2 lines. It'll treat it as a singular entity, and it's very nice. That's not something you can do through Onshape that I am aware of. So if we go over to this offset, click O for it. All it does is just give you a prompt to offset in a certain direction. So I have this orange, I have this large line selected. It's highlighted in orange. You can see this light blue dashed line over here is the line it wants to create as the offset. So it wants to put it on this side. We're going to say yes. And we're going to set that distance to 1/8 of an inch. So this is only half of our strand. The other half's going to go on the other side. So this strand width that we're going for is 1/4 of an inch. And just right there, I've changed it from construction geometry to a solid line because we want the solid line. So we're going to do the same thing over here. Same line, exact same line. We're going to change the direction. And we're going to go same width of 1/8 of an inch. And change that from construction to a solid line. So we have a total of 1/4 inch thickness, an 1/8 inch divided, bisected by the total line. If you are trying to save weight on your belly pan, you can make this thinner. I have seen people do as low as 5/32. Seen 3/16. It does make a little bit of a weight difference. I honestly wouldn't optimize that heavily for weight in this area, especially down low near your drivetrain is where you want weight. So I find 1/4 inch is good. I've seen people go more. I haven't really found that necessary, but to each their own. So we've done the 2 offsets for this line, and then we're going to take the other line and do the exact same thing. So we're going to offset that by 1/8 of an inch. I'm going to make that solid line offset by 1/8 of an inch, and this time reverse the direction. 0.125. Okay, so now we should have a more completed flag with actual different sections. So these 3 or 4 cutout sections. And this is exactly what we want. As you see, the endpoints aren't fully defined. I just don't care about that. If you really want, you can make them coincident. It doesn't change anything. So now that you have this, let me zoom in. This is our Bellypan in our part studio. We are going to extrude cut, so Shift E to extrude those 4 sections. Now by default, it's going to select some weird stuff, so I'm just going to deselect whatever it selects by default. I'm going to select those 4 triangles. I'm going to say remove. Through all, and merge scope should always be with this part, so I don't want to cut. If I'm doing this in one of these corners, I don't want to cut through one of these tubes by accident. But you'll see this little pattern here. We're going to say check mark, and that's good. And that's most of the work for creating the diamond pattern, because the next step is just the pattern, and that's going to be very easy, although it takes a second or 2 for the software to process it, but we'll see that in a moment. We're going to take this, we're going to pattern it however many times. And it's also now important to remember our magic number. So I'm actually going to go back to this sketch real quick. I need to know what this length is and what the other what the width length is. So this is 27.5, it says down here. And this is 24.5. So 27.5 and 24.5. Got to remember that. So now we're going to find the linear pattern feature in the features menu. So this is not a sketch. This is in the top level of features. Find the linear pattern. We're going to select a feature pattern. And under features to pattern, we're going to select extrude to. That's the one that we just made. Under direction, we're going to select our longest dimension, our length. You can see it's trying to go in a certain direction. We will change the direction. The distance is going to be that magic number, that 27.5, I think it was, 27.5. We're going to divide it by however many sections we had. And we chose 8 sections earlier, 27.5 divided by 8. If we did it right, there you go. That looks really nice. Our instance count is going to be that solid number. It's going to be 8. It's going to be whatever whole number we chose earlier. And you can see that pattern's perfectly over. And then from here, we're going to have a second direction, and we repeat the same thing. We select the direction, we select 8 instances, and it's going to go in some direction. We're probably going to want to flip that. And then I think it was 24.5 divided by 8. So I'm putting that info in. Onshape's taking a minute to load. But hopefully if we did this right, and I remembered the numbers correctly, because I didn't write anything down, it'll load magically, and everything will look nice. And we'll have our diamond pattern. And that's really all there is to it. Okay, well, we got the direction flipped. It's slowly getting there. There it goes. Okay, that's beautiful. Very nice. Say check mark to complete our command. And there's our diamond belly pan. This gets most of the work out of the way, so that's always very nice. So there's a couple things to do next. We need to make the cutouts for the swerve modules, and we need to mount the electronics. I don't think there is a right... Oh, the third thing is we need to add the actual fillets into the corners. We'll get there afterwards. Fillets are one of the last things you should do. But yeah, I don't think there's a correct order. I suppose you could do one and then the other, or the other and then the one. What I'm going to do is I'm going to make the swerve module cutouts first, just because it's easy to do. So I'm going to go to the bottom face. You can choose the top face, doesn't really matter, but I like working on the bottom because it's the most open. And what I need to do is find the size of the selection I want to cut out. So a couple things I can do. I can go over to my original sketch if you did your sketch this way. If I say show sketch, I see this corner right here. This shows my swerve module. This is the maximum dimension of the swerve module. I'm representing it as a square. If I actually go over to my drivetrain and I go down to the bottom, it's not a perfect square. There's a rounded corner here on the edge, but the dimensions are holding true. So that's really all I care about. And we can add a nice fillet in there later. But all I'm going to do is I'm going to create a little rectangle by hand. I know it's not perfect, but you make do with what you have. You could also, I suppose, just use the rectangle tool. Probably a better option. So make that line horizontal. I'll make this one vertical. This point is defined for some reason. I don't know why. There's that. Is it this line is coincident with the weird point? This shouldn't be defined. I am just going to do it the right way. I'm going to do the rectangle. As I always tell my students, do it right the first time. So I've got the rectangle. I'm going to bring this down here. And typically what I like to do is like 0.25 there. That way if I have a 0.25 offset, oh wait, nope, I need to do it from the, I'm still caught in my SolidWorks ways. I need to add the center hole, the point. I need to add the point right here because it's going to dimension it from the maximum or minimum of the circle, which is, I'm gonna be honest, that's pretty stupid, but not for me to decide. For the good makers of Onshape. Alright, so there's my rectangle. I'm going to basically select these lines. I'm going to use them as mirror lines. So I'm going to mirror this little rectangle to all four corners. Once I have it in all four corners, I will remove through all. All right, and I'm left with this little situation here. So I have this weird cutout. So in order to fix that, we don't want to just leave it. That's pretty bad practice. We're going to create a line that goes up and across. And that should be, assuming this line is horizontal, which Onshape is being very slow because I'm recording, so please bear with me. This line is going to be that outer surface, and we're actually going to want this outer surface to be a strand. So we're going to make our own manual strand here. This is one of those strand type CAD models. So I'm gonna make this little, this is gonna be material we're gonna add in. And it's going to be the same thickness as my strands. It doesn't have to be the same thickness as your strands, I suppose. I always do because I think it looks nicer. So that's gonna be a 1/4 inch for both of them. So there's a couple things we want to look at. And it's really these extenuating corners. We want to avoid a situation like this, where we fill in a weird tiny corner and create two tinier corners that we can't actually fillet. I can put one fillet on this corner. I can't put the same size fillet twice in here. It just functionally won't work. So I'm going to add a little bit of a fill-in. I'm going to add little details here and there just to make sure that we're not like I'd rather just turn this into a normal fillet rather than having two tiny corners that cannot be filleted. This is all fine. I want to fill that in anyways. This, yeah, it doesn't look like that extends over. So long as it doesn't extend over, it'll get filled in, and that's okay. And then over here, yeah, same there. And then I'll just I'll select the use command on this because I don't want to fill that in either. I want a singular contour. So this one actually looks pretty straightforward. That's nice. I always, when I do this, just deselect whatever it gives me, and it lets me select the contour I want. I don't really care about getting this area. There's nothing there. All right. Oh, careful. Okay. I think that should be okay. We're going to add this. Oh wait, oops, what am I doing? Silly Billy. Gotta mirror it. So the same thing we did with the cutout. We're going to create, oh, it's not letting me. Oh, because I'm not in a sketch. Just trying to use these construction lines using the use command, and it wouldn't let me. And silly me forgot that I had to be in a sketch to use sketch features. Funny how that works. But yep, go back to mirror. Select that line, drag and select everything, let that mirror over. Same thing over here. You could also do this with the mirror feature. Depending on who you talk to, some people will say that mirroring things in features is better practice than mirroring them in sketches, and they're not entirely wrong. But I think there's certain things I'll always do in sketches, and there's certain things I'll always do in features, and it's just important to have that level of baseline of which is which is more appropriate when. Yep, fill that in. I will say most things I will do as a feature. It's generally good practice for CAD. But for like this specific circumstances, like in Bellypan design, I will tend to put things into the sketch. So I have all these separate extrudes. I'm going to say I want to add them to the Bellypan, and I want them to go up to the face, the opposite side face. So I'm just going to select the face from the other side. So in theory, it should go right up there. That looks nice. And if I did this right, I can say okay, and there I go. Not too shabby, I must say. Not too shabby at all. I'm gonna hide this sketch now just to check a couple things. I think technically this is the correct orientation, or no, wait, this is the correct orientation. I really just inspect one corner unless I end up having a problem. Once you can confirm one is good, if you did them all the same, then they should all be good. So here we go. This is the Bellypan by itself. It doesn't have any attachment points yet. I'm just gonna real quick give it a name. Bellypan example 03, beautiful name. I'm going to give it an appearance and a material. For this one, I'm actually going to make it out of steel. And that's, again, part of the intentional desire to have weight down there. That's a good color for steel. Let's see, how heavy is it? Go to properties. I want something between like a 7 to 10 pound. All right, 6.1, not terrible, not great. If I really wanted to optimize for weight, I would probably increase the number of diamonds, something closer to 9 or 10. And the reason I say that these are good solutions is because this is something ultimately I will send out to Fabworks and have manufactured for us, and they don't care how many diamonds are in our Bellypan. So we can modify that to fit whatever our needs are. Alternatively, if we're actively trying to have less weight, then obviously first thing is start with an aluminum Bellypan. But then we can look into things like using more diamonds, or we could have a solid thinner Bellypan. So a great way to decrease weight is to just make it less thick. It's currently 1/8. 1/16 inch solid aluminum is a great lightweight solution for a Bellypan. But now on the next part, electronics mounting. So there's two ways to go around this. There's the top-down Onshape way, which fully utilizes the top-down design functionality that Onshape is built around. And then there's the bottom-up SolidWorks way, or not necessarily SolidWorks, but we used to use SolidWorks. So there's the bottom-up method and the top-down. The Onshape top-down method would be, we take this Bellypan, we insert it into the drivetrain assembly, and then we start placing electronics components. And once we have them all placed and permanently mated and fixed or fixtured, we will do an in-context edit of the Bellypan and add the features that way. The nice part about that is if anything ever moves, it in theory would update correctly, although this is such a complex geometry that getting it to update correctly is really annoying. And that is the theoretical proper way to do it. However, I have yet to find a way to use the mate connectors and the mates in Onshape in order to really easily position things, position the control system components at random orientations without having actual features to mate them to. So if I just want to place it in a very specific spot without having something to some other feature either in the component or in the control system component to mate it to, I find that difficult. In SolidWorks, my workflow would be I would have planes on everything, and I would mate with the planes, and the planes are always like symmetrical and centered on everything, and those were very nice. Or I would use things like the width mate, which allows you to put something in the very center of two other things. So I say, oh, I want my PDP or my PDH to be centered on my robot length. So I'll say it's centered along technically the width. If I want it to be centered along this axis, I would use either a plane in the middle of the oddly shaped and oddly dimensioned PDP and mate that centered, or I would get something like a width mate, and I would choose either side of the PDP and then either side of the tube, and it would automatically center. It makes it very easy. Onshape does not have that functionality, and maybe there's something I'm missing with mate connectors, but it seems like the best you can sort of do is an offset distance, which is annoying because it requires some amount of measuring, some amount of math. And if for any reason your drivetrain does change dimensions, suddenly you don't have that symmetry anymore because it's a hard-coded number that you're putting in. You can offset from a certain surface. So if I say this is 12 inches from the left-hand tube, it could right now be symmetrical with both sides. But if something ever changes, and let's say the robot gets a little less wide for some reason in early on, then that 12 inches is not going to be symmetrical anymore. So this is a long-winded way of saying I recognize that there is an Onshape ideal way of doing this, and I hate it because it's not the workflow I'm used to, and that's what any CAD user will tell you. If it's not the one that they know how to do, it's bad. So what are we going to do? What I've done is, if we go over to our electronics in our library, we look at our control system components. They're not all in here, but the ones that are in here have these little sketches in them, these little sketches with rectangles. And we're going to basically simple model the rectangles to be the control system components and their mounting hardware and mounting configurations. And we'll model that in a sketch, and then use the sketch to create the mounting functionality, the mounting features on the actual Bellypan in the Part Studio. So this is the Robo Rio. It has these tiny, I think they're 440 holes on the bottom for mounting. And then this rectangle represents the outside shape of it. I'm sort of just solving every control system component roughly as some sort of rectangle, because roughly they all are. So if I were to make this over in the sketch, actually, I'll pull it up right now. I'll show you exactly what I mean. So I'm going to say that, let me get this into the actual orientation. So if this is the isometric view, I'm going to say this is the front of the robot and this is the back. If I go over to my drivetrain assembly, front, back. So I'm going to say I want my battery in the back. I want my PDP or PDH somewhere in the middle, probably my Rio in the front. I'll put a VRM off to the side somewhere near the Rio, or between the Rio and the PDP off to the side. We have a radio to place somewhere, but that doesn't really have mounting holes, so we'll ignore that. And I think that's most things that we'll be using right now. Once you get the gist of how to do like the primary workflow, you can make this work for any control system component. So I'm going to start a sketch on the top surface. And I'm actually using the top surface this time and not the bottom. And the rationale behind that is I want to actually see the tubes, where things would intersect, and make sure I can account for that. So the first step is I'm going to say my battery is going somewhere. I need to figure out where my battery is going to go. So I'm going to model my battery as a rectangle. It's going to be a battery laying down. So if I go over to my electronics, I'll find the battery. Here, let me exit that for a second. Find the battery. There's no sketch on this, but I'm just going to put the battery in this orientation. So it's 7.1 inches wide and I'm going to say 6.6 inches long. 7.1 wide, 6.6 long, 7.1. And I actually just broke my own rule right there. I used the shorter distance for the length. So yeah, I guess there's really no consistency here. Just ignore anything I say. Do what works for you. That's the best rule. So I modeled this. I'm going to make a construction because I'm not actually using this geometry in a feature. Any geometry that you're not actively using in a feature, I highly suggest making construction. I made the center point of the line in line or horizontal with the origin, because the origin is a good point for me to reference because it is symmetrical with the component. Your origin in the Part Studio will not always be symmetrical with every component. So just be aware of that. And then my battery is going to be butt up right against my drive tube, but I don't actually have a drive tube here. So what I'm going to do instead is I'm going to show this sketch, and I'm going to use these lines again. I do love the use command. I love using old geometry, especially if it's relevant geometry, because then I can always go back. If I change the original one, everything else updates, and that's just good CAD right there. You'll love to see it. So I'm going to take this line, the inside line of my tube. I'm going to say use that. And it gives me a solid line. I'll turn it into construction because I don't want to actually use it for a feature. I just want to use it for reference. I'm going to mirror that line across. So select a mirror line. The center vertical line will be my mirror line, and the entity to be mirrored is going to be that line I just used. I realize now in doing this, I actually have this sketch. If you know, when I had that sketch hidden, I couldn't see it, but if I, you know, that's unhidden, I do have the sketch of the rectangle. I could use that, but I've got this already. So I have this dashed line to represent the tube wall. So I'm going to say my battery is coincident with that. Now I'm not going to have a specific mounting feature for the battery. There will be eventually be a plate that retains the battery that'll have mounting features. But I'm putting the battery here so I can figure out how much space I have for my PDP or for my RoboRio and so on and so forth. Also, I suppose now that I have this this center line, I can just use this for my next rectangle. So this is going to be my power distribution panel, or my power distribution hub, depending on which one you're using. And that is going to be modeled with two rectangles that share a center. And the rationale behind the two rectangles is important. The outermost one is the outermost dimensions and geometry for the control system component. So this is the physical space it takes up. So I know that I don't have two things intersecting. The innermost is going to actually be the mounting holes. So the holes that are built into the component that I want to line up with my Bellypan. So if I go over to CTRE PDB, I have the lines. We select the outer line that says 7.586. I think I can just highlight that and copy. Let's see if I can. I actually don't know if this works this way. I think that was good. I think that did it do anything? Yeah, okay. So cool. I've got that. I copied that over. Where is it? This one. And then same thing for the width. I'm going to highlight, copy that over. This is going to be the outermost rectangle. So that's the outer dimensions of the PDP. And then, let's see, we get this inside line. Oh wait, whoops, I don't want the parallel distance. I want just the length of the line. Maybe that number looked big. Now, a lot of these things, especially things made by CTRE, are just weird numbers. Like 4.110 is some arbitrary value that they figured was, you know, the right number. And then I'm gonna get the width dimension, 7.176. That's a size, all right. Those are numbers, and I can confidently say that those are numbers. Numbers no one's ever gonna remember, but that's why we have CAD models, right? And then I believe the PDB uses number 10 mounting hardware. Let's see, 0.21. Yep, that's gonna be a number 10. And we're gonna tap into this. Let's see. So I'm here. So yep, I'm gonna put number 10 mounting holes. So I'll represent these as circles. Set them all equal to each other. I'm going to say they're all 0.159. And then we have basically our PDH. We can slide back and forth and position however we'd like. So I'm going to say I want our PDH to be, or sorry, PDP to be 4 inches away from the battery. Why 4 inches? I don't know. It's an arbitrary size I chose. So there's that. I'm going to model the Robo Rio next. And it's going to be the same double, there it is, double rectangle. Because it has an outside perimeter that we want to model. And it has mounting holes on the inside that we also want to model. Alright, then we go over to here. I find NI Robo Rio. Let's see, the outside. If we actually look at it, orientation matters on this one a fair bit. We want it to be sort of like in this orientation. So what's this? This is 5.754, I don't know, something, just copy paste. And then the width, the length, or any of them, I don't remember which one is which, is copy pasted from this. Cool. And from here we need to get the mounting holes. So that's a, oh. And these ones are actually nice, so I can remember this one. This is 5 by 4. Yeah. Good job to NI. They made very easy to use numbers, and I appreciate that's about you. 5 by 4. Now the mounting holes. Oh, I think they are 440s. In which case, then we go to our handy dandy 440 mounting, or actually, oh, this one's gonna be separate. Because it's 440 tapped onto the Rio. So it's a 440 thread into the Rio, so I need a clearance hole. So 440 clearance hole is 0.112. Good to know. So for the PDP, we're putting the bolt into the, it's going to thread into the to the Bellypan. For the Rio, it actually is going to thread from the bottom through this 0.112 hole. I know that's not on the point, but I'll get it in a second. And it'll thread into the to the Robo Rio. That's some good design right there. That's real nice. This is also another advantage of using something like FabWorks, in that you can make whatever size geometry you want, and the laser will just make it work. Previously, when we made our belly pans on our routers, we wouldn't make tiny holes like 0.112 because we use a 4mm end mill for everything. So now we've got this. We probably want it a couple inches from our PDB or PDP. 2 inches looks okay. I see plenty of room around everything. Somewhere there will be a VRM, but I'll get to that later. Or, you know what? No, I won't get to that at all. I'm going to leave that as an exercise for the reader. So from here, we have our mounting holes. Now we need to actually create the material for them. So I'm going to create a circle around everything that needs material. Just like I would if I were adding a feature to an already existing part. Because that's really what I'm doing, is I'm adding a feature to an already existing part. And you're going to notice something. Some of these holes, or some of these little materials I'm adding, kind of out in the middle of nowhere. Really not anything, like they're not overlapping. Like this one especially, over here, it's out in the middle of nowhere. So there's a little bit of work that needs to be done for that. Now, I'm going to make these all 1/2 inch diameter holes, because it sounds right. Does it need to be 1/2 inch? No. Is it better off for not being 1/2 inch? Is there a more optimal way? I don't know. I don't think it makes that much of a difference, truth be told. So I'm going to make this as the sketch, and I'm actually going to leave this here. I'm not actually going to make a direct feature off of it just yet, and the reason being is I want to first make sure the holes are actually cut out holes. So like this one's overlapping, so I want to make sure I have material there. So I'm going to remove material. I'm just going to select all the holes, even if there's nothing there. Oh, no, not that. I want the hole itself. The reason I'm selecting the ones even if there's nothing there is if I ever add anything earlier in the feature tree, or if I change something and I want it to update correctly, it'll treat the hole like an actual hole. You want to make sure you have at least something that's getting cut out. If you have a whole bunch of contours selected and nothing's actually getting cut out, the feature will fail. So there's that. And then we're actually going to go back to the sketch. And beautiful, it's going to add that material in. We're going to make this up to face, up to this face. Merge with the Bellypan, and only the Bellypan. Very nice. So you'll see some of these actually work out real nice. So this one right here just needs some fillets, and it'll be a nice attached area. Same over here. Like the ones for the PDP are actually really nice. This all attaches pretty cleanly. It's already in line with a pre-existing strand, and it works nicely. The RoboReel ones are a little messy. So we're going to add some extra things to make them more nice to us. So typically for these, what I'll do is I will create a line to the nearest strand. If it's usually I just do one line to the nearest strand. If it's really out in the middle of nowhere, I'll add multiple mounting features. And then give it a minute. So that's perpendicular there. Make this line. Ooh. Let me redo that. What I'm basically going to do is I'm going to add material that goes between the floating hole, or the floating cylinder for the mounting, and the strands. I'm going to add that material in manually. So it's a bit of an involved process, but it takes a bit of time. But it's a surefire way to make sure your component is designed and built the way you want it. Also, looking at the time, I see that this video is almost an hour long. I'm not even going to apologize at this point. You just need this much time to explain this kind of stuff. So if you've made it this far, congratulations, or I'm sorry, one of the two. I'm sorry I happened to you. I don't know, is that how you would say that? It's technically my fault. Really? Whose fault is it to spread knowledge? That's what's going on here. Doing the good Lord's work. All right. That's a graphical error. I don't know what's going on there. Let's see. You'll make those lines all parallel. And Onshape's really having a bad day, because I'm recording video. There it goes. And I'm going to close off this contour. Make this equal or concentric. I think technically both. I think I can do equal, concentric, or tangent. That'll all work. Beautiful. So I have this little section here. That's fine. I could probably also mirror it across. So that's what I'm going to do. This guy's easy. I'm just going to select all three of these and say use. Because I just need to close off this. Fillets will fill in the corners here. Alright, so this is actually a really easy one. I'm going to go back to that top sketch that has the geometry I like to use. I technically only need one, but I'm going to use both. So I've got that, and I'm going to mirror using this as the mirror plane. I'm going to select those. Shift S for extrude. And it's preparing the extrude, very important. So we're going to say we're going to add this to the belly pan. Instead of blind, it'll go up to face. Select the opposite side face. Wonderful. And there you go. Oh, this didn't connect for some reason. Oh, you know why? I think I need to go to this and merge it. Yeah. I'll merge them all. There it goes. Beautiful. One piece. Awesome. So that's a belly pan with mounting holes for two control system components, and they're positioned how we want them. A final step would be to go to our feature scripts, and we'll say fill at all edges. Face. It wants a certain face. I forgot fill at all edges just from the top. So here's what I'll do actually instead, real quick. I'm going to do a normal fillet. I'm going to fillet the outside first. And the reason I'm going to do that manually, because these are going to be slightly different size. These are going to be 1/4 inch fillets. I'm not going to do this inside corner just yet. I'm going to do something fancy with that in a moment. Because I like doing the fancy style. You can judge, it's fine. So these are going to be 1/4. In theory, I could just say fillet them all, make them all the same size, and it will work. Like, it will be good, it'll be functional. It is no better or no worse for doing it this method. However, I like to make things look nice. So the outsides are 1/4, and that's all symmetrical there. And the inside is technically a 1/4 inch off of whatever, technically whatever this is. So that's 0.603, wonderful number. Ooh, where did I go? Oh, there. So I'm going to fillet these to be 0.603 plus 0.25. All right. So we want to basically fillet everything that needs to be a different size, which is what we just did here, the outside and the inside. And then we should be able to go to the feature script that says fillet all edges, and it'll fillet everything that isn't filleted. We want that to be an 1/8 of an inch fillet. And in theory, I should be able to select this face, and it should work, question mark. I've never actually done this on a belly pan. So let's see, it'll take a minute, but yeah, it looks good. Everything looks to be doing what it's supposed to be. Yeah, that all looks correct. check mark. Wonderful. Cool. And there's our filleted belly pan. That's kind of awesome right there. Very easy to do. It only took, you know, an hour. Like an hour exactly. It'll be much faster when you're doing it yourself. Or not. I don't know how good you are at this. There's our belly pan. We can insert it into our drivetrain. Let me see if we can get the right orientation. And we will mate it using a revolute and a cylindrical mate. So that way we can use 2 holes to mate it. So there's our revolute and our cylindrical. Beautiful. So cool. There's our pocketed belly pan. Everything looks good. Everything's in line. And now I'm going to real quick see, just to make sure that I did everything correct. I'm going to try adding the PDB in. I'll see if I can get my control system component to actually fit where I wanted it to go. So in theory, I should be able to do the same revolute cylindrical for 2 holes. So I'll select that one. And this mount. And then here's the real test. If we did it correctly, I should be able to mount this one cylindrical. And in theory, it should work. And if it doesn't, either we did our modeling wrong or their CAD model is not correct. Both are possible. If we exit, it looks like everything's fits, nothing's angry. Awesome. Yep, and you can see this is a tapped hole. There, everything lines up. That's sick, that's awesome. And yeah, like especially this is awesome for the PDB, or for the PDP, because we have our power wires running out of here, and we can just run them along these strands in groups, and we can zip tie them to the strands. And the wiring's nice and clean. All right, so that should be everything. Follow these steps, and you too can make your own diamond belly pan and Onshape. Alternatively, you could just not like do a diamond belly pan at all. That's always a great option. The only purpose for the diamond belly pan with the very specific mounting is if you're really trying to get those added functionalities and features through the strands, or if you're trying to optimize for weight and still want the 1/8 inch belly pan. But again, like if you're really trying to optimize for a lower weight, going thinner wall with less features is always more accessible. It's faster, it's cheaper. So you really want to weigh your options here and see which is the best solution for you. Either way, this is Andrew Lawrence. Thank you for watching, and I'll see you next time.